Hi, were we have stopped in the last class? Yes. In the case of the three-dimensional three variables, we have to define the directional derivative, its results, equation for the tangent plane and normal line. This is the equation for the tangent line and the normal line. This is the equation fx at the point p0 into x minus x0 plus fy at the point p0 into y minus y0 plus fz at the point p0 into z minus z0 equal to 0. Next, so this is the equation for the normal line. X equal to x0 plus fx at the point p0 into t, y equal to y0 plus fy at the point p0 into t, z equal to z0 plus fz at the point p0 into t. Next, an example. Find a tangent plane and a normal line of the surface f of xyz equal to x square plus y square plus z minus 9 equal to 0 at the point 1, 2, 4. First of all, we have to find out the del f, gradient. So gradient equal to fx into I plus fy into j plus fz into k. It's equal to 2x. Fx is 2x into I plus. This is 2y into j plus. This is 1 into k. At the point 1, 2, 4 equal to 2y plus 4j plus k. So the plane is therefore the plane 2 into x minus 1 plus 4 into y minus 2 plus z minus 4 equal to 0. For 2x plus 4y plus z equal to 14. And the equation for the normal line is given by x equal to 1 plus 2t, y equal to 2 plus 4t, z equal to 4 plus t. Okay, is it clear? Yes. Next example is, this is the surface. This is another type of problem. Given two surfaces, they are meeting at an ellipse. Find the parametric equation for the line tangent to E. Okay, this is a plane. This is a surface EF, and this is a plane what G. This two, the intersection of these two surfaces equal to this is that surface intersection, that is the ellipse. Meet at the point on this curve they have given a point 1, 1, 3. So how will you find out the tangent equation for the tangent line through this? So equation for the tangent line del f is equal to, first we have to find out this is a del f. This is del g. Del g means this is a normal line of this plane. This is a normal line. This is the normal line, normal vector. Normal vector. Sorry, this is not a normal line. This is a normal vector. This is a normal vector corresponding to this plane, and this is a normal vector corresponding to this surface. So its cross product is, you can say that this is a cross product that is normal to this curve. Normal to this curve. So del f cross del g is, we can find out this del f cross del g. Okay. So this del f cross del g is a normal vector at the point 1, 1, 3 on the curve ellipse. On ellipse. So we got a point and a normal vector. So how can you find out this? If we given a normal vector and a point, then we can find out the equation for the tangent line. This x is equal, this is the normal vector 2y minus 2j minus 2k. Point is 1, 1, 3. So x equal to 1 plus 2t, y equal to 1 minus 2t, z equal to 3 minus 2t. This is the equation for the tangent plane. So an equation for the normal line. Okay, so next is the plane's tangent to the surface z equal to f of xy. Z equal to f of xy means f of xy minus z equal to 0. This is the total surface. So here fz equal to minus 1. Fz equal to minus 1. This is actually the tangent plane equation. So here fz equal to minus 1 means I am substituting here. So the equation is equal to fx at the point x0 y0 into x minus x0 plus fy at the point x0 y0 into y minus y0 minus z minus z0 equal to 0. This is actually the equation for the tangent plane. Here in this type of surface, the z variable is z itself. So fxy minus z equal to 0. That is actually a capital F. So that fz equal to minus 1. So given a surface, we can simply calculate using the previous equation itself. You can find out the result also. Find the plane tangent to the surface is equal to fx and fy. We have to determine that's 1 and minus 1. So 1 into x minus x0 minus 1 into y minus 0 minus x minus 0 equal to 0. The equation is x minus y minus z equal by x minus y minus z equal to 0. Okay. So next is increments and distance. Increments and distance. Increment means that is a change. Increments and distance, that is a change in this. So estimating the increment means to estimate change in the value of the function or function f when we move a small distance ds from the point p0 in a particular direction u. Use the formula df equal to del f at the point p0 into u dot ds. This is the distance increment, this is the directional derivative. So the change in f is equal to the direction derivative into ds. Directional derivative into ds. So first we have to find the direction derivative. So that into ds is the change in f. So this is the problem. So estimate how much the value is, how much value of f of xyz equal to x e raised to y plus yz will change if the point p of xyz moves from 0.1 unit from p0 to 0, 0 straight toward p1 4 1 minus 2. We first find the derivative of f at the point p0 in the direction of the vector p0 p1 is equal to 2y plus j minus 2k. The direction of this vector is u equal to what? p0 p1 mod p0 p1 equal to the direction of vector given data. This is point moves from a point to this point. So equation for this line is equal to, equation for this is equal to, the equation of this vector is equal to, from P0 to P1, the vector equal to 2i plus j minus 2k. That is 2i means 4 minus 2 into I plus 1 minus 0 into j plus minus 2 minus 0 into k. That is 2i plus j minus 2k. This is a u actually. This is now not the u. U we have to find out. That is it must be a unit vector. So P0 to P1 divided by its modulus. So 2 by 3 I plus 1 by 3 j minus 2 by 3 k. That is a unit vector. We have to find out a del f also. Del f we can find out that is I plus 2j. So you do it please. That is we will get I plus 2j. So del f at the point P0 dot u equal to I plus 2j dot this u 2 by 3 I plus 1 by 3 j minus 2 by 3 k is equal to 2 by 3. 1 into 2 by 3, 2 into 1 by 3. 2 by 3 plus 2 by 3 equal to 4 by 3. So the change in df is equal to, here given that ds is equal to 0.1 unit. So del f at the point P0 dot u into ds. That is 4 by 3 into 0.1, which is approximately 0.13. This is the answer. Next is the algebraic rules for the gradient. Algebraic rule, constant multiple del into kf equal to k into del f. Sum rule, del of f plus g equal to del f plus g. Difference, del of f minus g, del f minus del g. Del of f into g, f into del g plus g into del f. Quotient rule, del of f by g equal to g into del f minus f into del g divided by g square. So, given f and g, del f equal to this one. So, del of 2f is equal to, which is equal to, okay, this is the problem. You have to do these problems also. You have to do these problems also.